This is Russ Anderson. In this tutorial, we're going to look at calibrating a full circle fisheye lens based on an image that contains a bunch of straight lines. So the calibration software is going to worry about making those straight lines actually straight. And one of the nice things about fisheye type of lenses is because they have specific shapes to the kind of distortions that they create, you can actually calculate the field of view. So the calibration is going to do that. Now, to start this process, we're going to access some comparatively little used features in SynthEyes that are on a flex panel. So I'm just adding the room for that so that we can get a hold of it. You see it over here. And basically it lets us create 2D and 3D straight lines. So we're going to use these curves to point out exactly where the straight lines are in the image. So the idea, we did the new curve, and now I'm just going to start clicking along an edge in the image. You can see I'm just kind of doing this approximately to start with. Now once I reach the end, I'm just going to right click, and that terminates that process. Now I'm just using the middle mouse button to go back and zoom in, and the middle mouse button again to start refining these control points to get them more exactly right along this line, this edge in the image. Oops. Now, you notice I don't have quite enough control points yet, so I can just go and hold down the Shift key and click and create additional control points wherever I need to. As I do that, I just keep on working my way through this image along that edge. I'm not really concerned about exactly where it ends. We're just trying to get it so that all the way along this edge, the line is showing exactly where that edge is. And it does need to be something that's actually straight in the real world. So I did that once. Now let's go and we'll do some more. Wherever you are putting a line, you just want to make sure that you're consistent all the way along the length of the line. You can see if I don't click on the line, it'll get unselected. One thing, if I just try and move the line here somewhere where there's no control point, that'll wind up moving the entire line, which is generally not what you want. So you just have to make a little care that you don't move the whole thing. So there we've got another line. Now we'll just keep on going some more. So you get the idea here, and I'll just kind of keep on doing this and we'll speed things up. You'll notice I'll try and get a variety of different orientations for the line. I've got some that are predominantly vertical, and I'm going and picking up this one here that's more horizontal, just like I have the one across the top of the roof. One thing that I'm not going to do is pick a line like this one here. Lines that are predominantly radial don't give any information to the solving process, so there's no need to use that. Or lines like in here or there, they're not going to add to the calibration process. In the same way, you do want to have a mix of different things here. Lines that are exactly around the circumference aren't as helpful either. So lines that have a bit of a diagonal to them are good. And here, this line here, kind of is closer into the center for a bit and then heads further out. So that contributes more information to the overall calibration process. I'll point out the curves can actually be animated over a whole sequence of frames, but the line straightening process just uses the information from a single frame. So we've got a number of lines set up now, so we're going to move on to the next step, and that is to create a vignetting mask. So we've got a lot of the image that isn't really doing anything useful. So I'm just going to create a circle right across the middle of this thing. You'll notice that on a large scale like this, our circle isn't actually all that super circular. So I'm just going to add a few more control points to it. You don't normally bother with when the circle is smaller. And part of the time the spline is off the edge, and so we don't want to be telling SynthEyes that there's any useful image out there. So I'm going to add some control points right at those boundaries, and now I can shift right click and take these control points out. Now I'll double click to change those into corners. So this vignetting mask is important in some of the other kinds of output formats that we'll be using in kind of other examples, where it's really crucial to know, where's the real image and what don't we have to worry about. And that's crucial if you're trying to make sure that the image contains 100% real image pixels and not any of the black pixels, or alternatively that the image contains all of the actual image pixels but doesn't contain anything more than it really needs to. So another number that we're going to need is actually the size of this circle. So you can get that just by positioning the mouse at the left edge of the circle and look down here on the status line. You can see it's reading about minus 0.731 here and 0.706 at the other side. So we're going to say the average is around the 7.2, maybe 0.72 as the diameter of the circle. And that's giving you some information about where the center is right away, but SynthEyes is going to figure that out more specifically in a little bit. So we're ready to start the calibration process now. So to do that, we're going to fire up the lens master calibration script, and it has a whole variety of controls here. So first off, we want to say that we want to straighten the lines. That's the overall kind. We're going to start out with a fisheye lens. You notice there are actually a variety of different kinds of fisheyes. We're going to wind up determining which is the best fit to this particular lens. And to do that, we don't want to have any secondary distortions on top of this fisheye calculation. So we're going to leave the distortion equation that adds to the basic underlying distortion. We're going to keep that as a none. We're going to say we want to compute the lens center. We want to compute the field of view. We're going to estimate the field of view at 160, something like that. It's going to be obviously quite large since we're really running out all the way towards 180. And you'll see we've got our lens radius here that we figured out by measuring across earlier. And normally I'd have to type that in, but that was just a value from previously. So we've got that. So we'll hit OK. Now we get the second panel from this script, and we get to select what kind of output format we want. And for starters here, we're just going to be determining what sort of lens we've got, and we'll leave the workflow setup at none, and we're going to set the apply fix to scene to be turned off. So we're just going to be doing the calculation itself. So we'll just hit OK. We get a little message that it's going to be basically sitting there computing for a while, and it can be quite a while in some cases. But here we're just doing the basic calculation, so it's really quite quick. I think we need to turn that off. So there's our first calculation. Now we're just going to do that process again. Instead of fisheye, we're going to do an equisolid. But OK, we'll turn off that message. And here's our next version. So now you can see we've got a readout of what sort of errors we get from this data for each of the different lens types. So of these different kinds, the equisolid one is generating the lowest error with no secondary distortion added in. So we'll conclude for this that the best match to the kind of lens that we have is that it's an equisolid lens. So now we're just going to hit undo a couple times and get rid of those. Now we can go back, set it to equisolid, and maybe we now will allow a little quadratic distortion to be on top. As far as the output format now, the field of view here, since it's so large, we can't really convert to a conventional linear image format. Basically, the closer the field of view gets to 180 degrees with a regular linear lens, the larger the image plane needs to be, and it gets to be hugely large, and basically it's going to infinity as it approaches 180 degrees. So that's not useful for these wide-angle fisheyes. And of course, some of the fisheyes can go past 180 degrees also, and that's completely impossible with the linear types of formats. So one of the options that we have here is to go directly to a 360 VR format, and that's what we'll do here. So we'll say that we do want to apply the fix to the scene. We're going to generate a 360 VR format, and we've also permitted the additional little bit of lens distortion correction to be added. So now we'll do the running, and it's going to take a bit longer now because not only are we doing the calibration itself, but now we're generating a bunch of image maps that say how to switch back and forth between these formats. And we're actually doing the conversion of this image into the 360 VR format. So it just takes a little bit longer. And you'll see the little spinning wheel down there. And SynthEyes is apparently hung just because the way that this is put together with scripts, we can't really put it into the background at this point in time. So now we do have the results of the conversion. Looks a little bit wacky. Here we've got a mesh that contains the distortion, and we could actually apply the image to this mesh as a texture if we wanted to. So let's see what we can do here. Let's go over to the perspective view, and we'll lock that to the camera. So now I can look around in the scene. This is, basically looking around in different directions within that 360 VR sort of scene. And you can see that the lines that we set up, and really even the lines that we didn't set up, are now nice and straight because the calibration did its thing. You can even look down towards the bottom. And, obviously we don't get a full 360 VR circle just because we have only, one image. But we do have something that we can look around in nicely. So what we can do now, the calibration has generated a preset, which is a TIFF image file, and that's actually sitting out there right where the shot image is due to the choices that we made on that output panel, which are really just using the defaults. So we can actually apply that image in the image preprocessor. If we go to the lens panel, you'll see that this UV map, image distortion map, SD map, whatever kind of map you want to call it, it says how to translate our fisheye lens into a 360 VR format. And it's encoded as a colorful little image. And we've used that as a lens preset here in the image preprocessor. Similarly, I'll point out it's also been set up so that it's a 360 VR image. Now, one of the cool things you could do now is if you've gone around and done a survey of a set using your fisheye lens, now you could just apply this preset image as the lens distortion map to all of your fisheye lens images, and then treat the whole thing as a set survey using the regular SynthEyes survey shot features to be able to build up, your model, 3D model of your set. The thing that's nice about that is because it is a fisheye lens, it gives you a whole lot of, viewing direction at any given location. It does make it easier kind of to tie all the individual images together. You don't need quite as many, and it's easier to understand sort of what connects to what. Typically, you do have to use some supervised tracking when you're using set surveys because there's not continuity from one image to another. But at least with the fisheye images, it makes it pretty easy to look at two of them and see really what goes together. A lot easier than it does in a regular image that has a much smaller field of view. So the big field of view is really helpful for the survey shots as long as you got everything nicely calibrated. So hopefully that is a useful technique. And now you see how you can do some nice fisheye calibration. Thanks for watching.